Hi, once again, welcome to Varenya's Photon Online Educational Academy. This is Guntuka Srinivas. This is a free online educational channel meant for students of 8th standards to the 12th standard. In these sessions, we go slowly from the fundamentals, then to the advanced levels of learning. If you like the video, please share it, encourage the channel, and please subscribe the video. In the previous session, we have seen about the distance. Now let us see in this session about the displacement. Let us see about the displacement. What is meant by displacement? When an object changes its position, displacement occurs. Observe carefully the statement, what it says. When an object is changing its position, then the displacement occurs. Observe, let us say an object is at this point at x1 position. This is the initial point, let us say. And slowly the object is moving towards another point. Let us say x2 position. This is the final position. Clear? The x originally the object was at x1 position, which is initial position. Slowly the object moved to the x2 position, which is the final position. When the object is changing from the initial position to the final position, or there is a change in the position, then displacement occurs. Here, then the displacement occurs. Observe, in the previous classes, we have seen about the position vector. Observe, displacement in terms of position vectors. Displacement in terms of position vector. Try to see. This is x-axis. This is y-axis. This is r-axis. Let us say the object is present at this position A, at time t1. Yeah. I am indicating the position of the object with reference to the origin. I connect from origin to this object. This is the position vector. This is position vector. So origin to this point A. This is a position vector. OA bar is a position vector. Let us say I indicate as R1 bar. OA bar is R1. Here I write clear. OA bar is R1 bar. It is a position vector, initial position of the object at A, at a time T1, at the time T1. Let us say slowly, the object has moved to the B position. Object has moved to the B position and the time is T2. And if I connect this, if I connect with this B position by means of vector, OB bar is the position vector. OB bar is the position vector which I am indicating as R2 bar. OB bar shows the final position of the object. OB bar is equal to R2 bar. Shows the final position of the object. Now observe carefully. Once again, initially the object was at the initial position A at the time T1. The initial position of the object is indicated by the position vector with reference to origin OA bar, R1 bar. I am indicating this. Clear? Now, as the object is moved from T1 to T2 time, within the T1 to T2 time, it has moved from A position to the B position. B is the final position. Now I'm indicating the final position of the object by means of origin by connecting a vector OB bar. This is a position vector. Final position of the vector OB bar is R2 bar. Okay, that means object is changing A to B position. When the object is changing its position from A to B and connecting this A to B, connecting this A to B by means of a vector, this AB bar is known as displacement. So AB bar is known as displacement vector. Displacement vector. Clear? Displacement vector. Now this I am indicating as delta R bar. Delta R. Clear? So I want to indicate this delta R bar, that is AB bar, is in terms of position vector. In the previous session, we have seen AB bar is OB bar final position minus initial position. So OB bar minus OA bar. B bar minus OA bar. So clearly it indicates that AB bar is displacement vector, OB bar final position vector minus initial position vector OA bar. This AB bar is delta R bar. Final position vector is R2 bar minus initial position vector R1 bar. This we also have seen by means of triangle of addition in the previous session. Just go through those videos, you can easily understand. Clear? So this is the displacement vector in terms of position vector. Final position vector minus initial position. There is a change in position. Wherever there is a change in position, there occurs the displacement. Clear? Okay. Now, observe carefully. Whenever there is a change in the position, we said that the displacement occurs. Clear? So here I have shown that previously x1 position, initial position, to the x2 position, final position. Object is changing from initial to final position. So what is the displacement? Displacement is displacement is equal to final position minus initial position. Okay, that is x2 minus x1. x2 minus x. Clear? That means displacement, no, I'm defining. Displacement, no, I'm defining. Displacement is the difference between final position and initial positions. Is it clear? Displacement is nothing but the difference between final position and the initial position. Okay. Now, observe, what is this displacement? Is it a scalar quantity or a vector quantity? Displacement is a vector quantity. Displacement is a vector quantity. Have the clarity. It is a vector quantity. Clear? Is a vector quantity. Whereas in the previous session, we have seen distance. Distance is a scalar quantity. That's all. It has only magnitude, no direction. But here, displacement is a vector. Once we say it is a vector, means it has, displacement has a magnitude. It has magnitude also because a vector, and it has direction also. Yes, direction also. Magnitude as well as direction. Clear? Now, what is its magnitude? Let us see. What is its magnitude? First one, we have to see magnitude. The magnitude is simply the shortest distance between initial and final positions. Initial and final position. How the clarity in this? Very, very important. It is the shortest distance. Shortest distance between which positions? Initial position and the final position. This is nothing but the magnitude. Magnitude can also be defined in other way, or simply I define in the other way also. The other way here also I am showing magnitude. Here I am showing magnitude. Another way, magnitude is the length of straight line, joining the initial and final positions. Initial and the final position. In this way also you can define what is length of straight line joining the initial and the final position. Initial position as well as final position joining length of the straight. Or simply It is the shortest distance between the initial and final position. This is nothing but the magnitude of displacement vector. Clear? Now, what is its direction? Let us see the direction also. V1, we want the direction. Because it is a vector, it is having a direction. What is its direction? Direction is always from, be careful my wording, from initial position to final position. Initial position to the final position. This is very, very important. Direction is from initial position to the final position. Magnitude is nothing but length of straight line joining the initial and final positions, whereas direction is always from initial to the final position. Clear? Observe carefully. Let us take up one simple example. Okay, a simple example, I take it. This is a point A. Let us say this is a point B. Clear? This is a point B. Now, we have traveled from the initial position to the final position B by means of this path. Path 1, case 1. We have traveled this A to B by means of this path. Previous session example only I am taking. There is a second one. Initial position to final position, we have traveled by this path. Let us say we have traveled from A to B by means of this path. Third case. So, case 1, A to B, this is the distance traveled. Case 2, A to B, this is the distance traveled, initial point A to final point B. Case 3, this is the distance traveled, initial point A to final point B. Now, all these are distances. But what is the shortest path? Observe. If I join the initial point and the final point, what is the displacement meaning? It is the shortest distance between the initial and final position. If I join the initial and final position, this becomes the shortest distance. So, shortest distance between initial and final positions. Clear? Initial position is A, final position is B. This is known as AB, is known as displacement. AB bar. Now, first one is also distance, second one is also distance, third one is also distance, fourth one displacement is also distance, but it is the shortest distance. Displacement is the shortest. Yeah, displacement is also distance, but it is the shortest distance. Clear? Between initial and the final position. Okay. Now, observe magnitude is from straight line connecting initial to the final position. And what is the direction? Direction is always, I told direction is always from initial point to the final point. From initial to final. This is the direction. So AB bar is displacement. AB bar is displacement vector. Direction is from A to B, initial to final. Clear? Now, observe. We said that displacement is a vector quantity. What are its units? The units are same as the distance. Units are either in the meter per second or centimeter per second. What is the dimension? Dimension formula. Dimension formula for the displacement. Okay. M to the power of 0, only L, and T to the power of 0. Because L is the only dimension. L is only that L we are representing in this form. So units, dimension, form. Is it clear? Now, let us take up some examples to explain this concept, displacement. Observe, in one-dimensional motion, in one-dimensional, this straight line motion, let us say I am taking, this is origin, this is origin. Clear? Now, these are all the distances. These are all 10, 20, 30, 40, 50. Scale I am adopting. All are in kilometers. Let us say, initial point is 1, and it has moved up to the 50 kilometers. Initial point is 1, moved up to the 50 kilometers. Let us say it is A. Final position is A. Clear? What is the distance? What is the distance? OA is the distance. Clear? And what is the shortest distance in the straight line path? Shortest is also connecting initial point to O and final point A is OA1. That means OA is distance. Okay. How many kilometers initial to final? 50 kilometers is the distance. What is displacement? Here I am showing the displacement. What is the displacement meaning? Shortest distance between the initial to final point. Initial point is O, final point is A. In the straight line motion, the distance is always equal to the displacement. Clear? From it changing from initial to final position, in this case, distance is equal to the displacement. So OA bar is also 50 kilometers. Both are equal in the straight line. Distance as well as displacement. Shortest distance also the same, OA. Okay. It is the magnitude is straight line joining from the initial to final. 0 to, that is O to A, 50. And what is direction? Direction is from O to initial position to final position. OA, O to A, O direction is from A. Clear? Now I write a conclusive statement that in straight line, in the straight line, distance and displacement in above case, be careful, in above case are same. Only in case of straight line, that too in the above case only. Clear? Now, let us take another example. So, here, example 2, right? Example 2. Let us say this is a straight line. This is origin. This is the positive x-axis. This is negative x-axis, x bar. Clear? I am adapting some scale here. The scale is here. The 10, 20, 30, 40, 50, 60, all are in kilometer, let us say. Yeah. Now, let us say that the object is at initial position, that is the at origin initially. It has gone up to the point P. It has traveled P. It has traveled P. Yeah. Then it has come back from P to Q, somewhere here. Q. Observe. Object is from here O initially. It has initially traveled to P. Then from the P to it has come back to Q, backward direction. Q has. Now I need two things here: distance as well as displacement. Now, what is the distance? First one, we are interested in the distance. What is distance? Distance, how much? From O to P. First, it has gone O to P. O to P has gone. Then P to Q. P to Q. So O to P is how much? 60 kilometers. Plus P to Q is how much? Here to here is 20. Here to here is 60. So difference is 40. So 40 kilometer. Total distance is how much covered? 100 kilometers. That was the distance. So distance, even if it is a backward, no magnitude, only magnitude, no direction. Just simply adding O to P, 60, P to Q, 40. In backward, no need to take any direction. This is scala. So 60 plus 40, 100 kilometers. Now, I need displacement. I need the displacement. Second, I am interested. Displacement. Displacement. Observe. Here too, first initial position where it has gone, P. Then final position where it has gone, final position is Q. Initial position. This is the initial position. Then final position is this. Final position. Initial position and the final position. What is the displacement? Just now we have seen displacement is what? Displacement is what? Change in the position. It occurs due to change in position. Okay. What is the simple thing that the magnitude I need? The straight line joining the initial position. Length of the straight line joining from the initial position to the final position. So initial position is P, final position is Q. Joining these two joining. How much is displacement? 40 kilometers. Okay, this is magnitude. What is magnitude? Length of the straight line joining from initial to final position. If I join, the difference between 60 and 20. Here, year to year is 60. Year to year is 20. 60 minus 20 is 40. Magnitude. Clear? Now, what is the direction? Direction we said from the initial point to the initial position to final. Direction is like this. Direction is initial to final. Direction, initial to, that is P to P to P2. Means, what is this displacement vector? Displacement vector is P to Q. PQ bar. Direction is from P to Q. Initial to final. Is it clear? So we got in this case magnitude as well as direction. Okay. Magnitude as well as direction. Is it clear? No, you may get a doubt. Directly, you can also get from final position to the difference between the final minus initial. Okay, this we can also see final minus initial. Final position minus initial position. What is final position? OQ. OQ bar minus initial position OP bar. Year to year OQ 20. Year to year initial 60. So minus 40 kilometers. That means directly you can attack final minus initial position. So 20 minus 60 minus 40. This minus 40 involves magnitude 40 and direction also. Negative means reverse P2. Involves both the things. Whereas in the earlier case, we have separately calculated. Magnitude separate, direction separate. Clear? Now, observe. Let us take up third example. Let us take up one third example. Okay. Observe, this is a position at A. Object has moved to the position B. Again, it has come back to the A. It has gone A to B. Again, reverse, it has come to the initial position. Clear? Let us say it as example only. 40 kilometers it has traveled from initial to final position. Again, from B to reverse 40 came to the same point. Now, in this case, what is the distance we want? Distance. Distance is first initial to final 40 and reverse B to A 40. So 40 plus 40. No magnitude. No, so only magnitude. No direction. 40 in this direction. Again, reverse. Don't think reverse minus. No question of negatives. Only magnitude. 40, 40, 80. What is displacement? Observe. Displacement in this case. Year to year. Then again came back. Wherever the started initial position. Again, it is also the final position. Initial, final position become same. So same point, there is no displacement, zero. Magnitude is zero displacement. Zero displacement. Zero displacement. Okay. That means it is a null vector, 0 bar. Null vector. Null vector. Because displacement is vector, so it is a 0 bar, null vector. What is the meaning of null vector? In the previous session we have seen, it is not having any magnitude. No magnitude, I. That means 0 magnitude. No specified direction. There is no direction because initial and final positions are coinciding. No direction. No specified direction. Clear? But distance covered is there. Okay. This is another example that we have seen. Is it clear? We have seen another example. Clear? Now, in conclusion statement, I would like to add that displacement okay, can be zero. In the above case, it has become, because it has gone this side, again it came back like this. Again, it came back like this. So displacement can be zero, but distance cannot be zero. Cannot be zero. Clear? That means, remember, the distance is always greater than the or equal to the displacement. Greater than or equal to displacement. What is displacement? Shortest distance. Distance, either in the straight line it may be equal, or always it is greater than the displacement. Very, very important point. Be careful. This is very, very important. In the straight line, it may be equal, both distance and displacement. But always displacement is a shorter distance, hence distance is always greater than the displacement. Clear? Okay. I hope you have understood the concept displacement clearly. To practice well, when you are practicing the problems, you will notice the difficulty in solving the problems. And I told in the previous session that practice is the key to the success. So understand the concepts carefully, go through them twice or thrice, then you attempt some problems on your own. You can easily able to solve. Is it clear? So if you like the video, please subscribe it, encourage the channel. It's a free educational online channel. Okay. Thank you. Thank you very much for your patient listening.